The stillness of the outskirts was torn apart by urgent emergency calls. The driver reported in panic as million-dollar machines were slowly sinking into disaster. When traction disappears, multi-ton machines become nothing more than motionless blocks of steel. Time does not wait, and the terrain shows no mercy. Today, there is no room for mistake. The first rescue target of David's team that morning was the American Coach Allegiance, a high-end RV nearly 13 meters long, weighing 45,000 pounds. The scene, a dry lake bed. The surface looked like hardened sand, but just 12 inches below lay deep, sinking mud. The RV had sunk down to its chassis, completely immobilized. David immediately deployed an 8-wheel heavy recovery truck from Sparks Motors, equipped with a 50-ton rotating crane. The initial plan: attach the cable to the rear tow hitch. But with a loud snap, the entire steel hitch was torn off the frame. The resistance from the soft sand far exceeded expectations. The strategy changed instantly. The cable attachment point was then moved to the axle, a structurally stronger position capable of handling the pulling force. While repositioning to pull from the front, the recovery truck turned too sharply on the unstable ground and got stuck itself. The situation flipped. The rescuer became the one needing rescue. A 3-axle rear-drive Kenworth truck was brought in. First, the Kenworth pulled the Sparks truck out of the mud. Once it reached firmer ground, Sparks reattached the cable to the RV. There was no stopping. Stopping meant sinking. The nearly 20-ton mass of steel was dragged continuously for 2 miles, until the wheels finally reached solid asphalt. The rescue was successfully completed, a clear demonstration that in complex situations, precise technical calculations and coordinated use of heavy equipment are what make the difference. Late in the afternoon, gray clouds blanketed the sky, cold winds cutting through a busy intersection as we approached the scene. A MAN TGS hauling a nearly 16-meter Termat silo trailer had overturned onto its side near the shoulder. Long skid marks etched across the road showed the driver had taken a sharp turn to catch the final green light. The center of gravity was too high. Centrifugal force alone was enough to bring the entire rig down. The truck body and silo crushed through the metal divider, sliding and leaning against the sloped embankment. Inside the tank, a full load of 40 tons of dry cement, pushing the total weight of the combination close to 57 tons. The tractor's chassis had endured severe torsion, while the aluminum silo shell remained highly vulnerable to deformation. After careful deliberation, we deployed 2 Volvo FH8x4 rotators, equipped with Omar's cranes and hydraulic winches rated at 60,000 pounds per line. Before any pulling began, the team excavated beneath the silo to position high-pressure air lifting bag. Once inflated, the 57-ton steel mass was raised just enough to thread wide Kevlar straps underneath, distributing the pulling force without crushing the aluminum shell. The tactical layout was executed with precision. Unit 1 positioned perpendicular, boom extended at 30 degrees for the roll. Unit 2 anchored at the rear, cables set at 45 degrees to stabilize as the center of gravity shifted. As both winches engaged simultaneously, total pulling force exceeded 100,000 pounds. The ground trembled slightly. Metal screamed under tension. The most dangerous moment came as the center of gravity passed its tipping point. Instantly, both units transitioned from pulling to holding, releasing brake pressure millimeter by millimeter, using cable tension to control the descent of 57 tons of steel. Finally, all 6 axles touched down safely on the road. "26 miles south of the second scene, John's team was facing another complex recovery on a narrow road cutting through open field. A yellow Demag AC 100-4L, a 4-axle all-terrain crane weighing 48 tons, had slipped off the soft roadside, fallen into a drainage ditch, and rolled onto its side at a full 90 degrees. The cabin and boom system were pinned tightly against the damp ground. Due to the crane's complex structure, conventional winching was immediately ruled out. High friction and sensitive hydraulic systems meant dragging could cause severe damage. There was only one solution: lift the entire 48-ton machine into the air and reposition it safely. Primary lifting force was assigned to the Liebherr LTM 1500 to 8.1, an 8-axle crane from Peterburs with a maximum lifting capacity of 500 tons. At the rear, a Liebherr LTM 1090 from Canisius handled the 90-ton counterbalance. Heavy-duty fabric slings were routed through structurally reinforced point. The 500-ton crane took the main body at its center of gravity, while the 90-ton crane supported the rear. Everything had to be perfectly balanced before the engines roared to life and the cable systems took on the full 48-ton load. The steel mass slowly separated from the mud, then lifted completely into the air. At that exact moment, a Mercedes-Benz Actros hauling a multi-axle Goldhofer low-loader trailer began reversing into position. Suspended mid-air, the two cranes worked in perfect coordination, rotating the crane body parallel to the trailer. The 48-ton mass was then lowered slowly, precisely, until it made perfect contact with the trailer bed. The crane was secured safely, ready for transport and repair, bringing an operation measured down to the millimeter to a close. As the final rescue lights dimmed, silence returned to the roads. More than 150 tons of steel had been restored to safe balance. In this line of work, the greatest reward is not simply recovering the vehicle, it is completing the mission without a single additional structural failure. We packed up the equipment, checked every cable once more, and stood ready for the next challenge.